Some galaxies were once right beside us, now they're gone, not because they vanished, but because they're moving too fast for light to ever catch up. And if you think you understand the universe, you may have only seen the part it allows you to see. Chapter 1. The universe isn't infinite, and neither is our sight. You've probably heard people say that the universe is infinite. Ever since the Big Bang, light has been traveling outward, but light moves at a fixed speed. It is not a limit of how big the universe is. It is a limit of how far we can know. It doesn't matter how powerful your telescope is. If light from a galaxy hasn't had enough time to reach us, then it's as if that galaxy doesn't exist. At least from our perspective, we're seeing them as they were billions of years ago. Some of them may have collided, exploded, or changed completely by now. We're literally looking at cosmic history, written in beams of ancient light, too far for light to reach us in the lifetime of the universe. It's a hard limit. Like looking at a photo album where the last few pages are blank, not because there weren't moments worth capturing, but because the camera hadn't been invented yet, and beyond a certain distance, no matter how good our instruments get, there is simply nothing to see. But we'll never know, because their updated light hasn't arrived, and it might never. That it goes on forever in every direction, without an edge, without a center, and in a way, that might be true. But here is something not many people realize. What we can actually see, the so-called observable universe, is very, very limited. But because of time, because of light, but due to the stretching of space itself, a process known as cosmic expansion, the most distant light we can see comes from objects that have since moved far, far away. Reminds us of our place in a story far bigger, far older, and far stranger than anything we can fully grasp. Not because we're too late, but because the rules of space-time won't let us follow. Every second, more and more of the universe slips into view as light from ancient stars and galaxies finally reaches us. We're constantly uncovering new territory, like explorers watching new lands rise from the sea. But at the same time, something unsettling is happening. Some parts of the universe are receding faster than light can travel. Some of them no longer even exist in the form we see them. And some are now so far that even their light can never catch up. They've passed the so-called cosmic event horizon, the absolute boundary of causal connection. They could explode, burn out, or birth entire civilizations, and we would never know. We're staring at ancient light, echoes of the past frozen in time. Let's step back for a moment. Imagine you're in the middle of a pitch-black field at night, and you light a candle. In that darkness, the glow from your candle only reaches so far. Everything beyond that radius stays dark, not because there's nothing there, but because your light hasn't made it that far yet. That's exactly what our universe is like. We humans, Earth, the Milky Way, are like that candle. This invisible wall around us is what scientists call the observable universe. So, here's the strange truth. The universe might be infinite, but our view of it, it's very, very finite. Right now, the observable universe extends about 46 billion light-years in every direction. That might sound strange considering the universe is only 13.8 billion years old. Take a moment to let that sink in. When we look at distant galaxies, we aren't seeing them as they are. This means that the deeper we look into space, the further back in time we're peering. Nothing. Not because space is empty, but because it's too far. But here's where it gets even more surreal. The edge of the observable universe isn't fixed. It's expanding, just like the rest of the cosmos. Because space itself is expanding, distant galaxies are moving away from us, not through space, but with space. Think about that. Entire galaxies, entire possible histories falling permanently out of reach, and still, we look up. We wonder. There's something hauntingly beautiful about this limitation, about knowing that no matter how advanced we become, some parts of reality will always be off limits. It humbles us. And yet, this isn't the end. This is only the first step, the edge of the map. Beyond this lies a question far more mysterious. What happens when the galaxies begin to vanish, one by one? Chapter 2. Galaxies are vanishing because we're drifting apart. It might sound like science fiction, galaxies disappearing into the void, but it's not fiction. It's physics. It's happening right now. To understand why, we need to revisit a strange discovery made in the late 1990s. Astronomers observed something unexpected. The universe wasn't just expanding, it was accelerating. Scientists call it dark energy, an invisible force that seems to permeate all of space, driving its rapid expansion. We don't know what dark energy is. We only know what it does. It pushes galaxies away from each other at speeds that eventually exceed the speed of light. Galaxies weren't drifting apart at a constant speed. They were being pushed away faster and faster. as if space itself was stretching with increasing urgency. Yes, but there's a loophole. Objects can't move through space faster than light, but space itself can expand as fast as it wants. What's causing this? Wait, isn't that impossible? Doesn't Einstein say nothing can travel faster than light? Not now, not ever. Those photons are essentially running on a treadmill that's moving faster than they can. No matter how long we wait, they won't arrive. This means that distant galaxies are being carried away on the swelling fabric of space, like spots on an inflating balloon. It's not just a technological limit, it's a physical one. Not because the stars are dying, but because they're fleeing, because the universe is taking them away. A law of the cosmos. And some have now crossed a point of no return, the cosmic event horizon. Beyond that horizon, even if a galaxy shines as brightly as 1,000 suns, its light will never reach us. So what does this mean for the universe? We observe. In the far future, all galaxies beyond our local group will fade from view. They'll still exist, but for all practical purposes, they'll be gone. To them, the night sky will be emptier, lonelier. They may look up and wonder if the universe always looked that way. It means that our cosmic neighborhood is shrinking not because space is collapsing, but because we're being left behind. One by one, galaxies are vanishing from our skies, slipping silently beyond the boundary of knowledge. Let that sink in. There are galaxies visible in our telescopes today that future civilizations will never know existed. And the most haunting part, there's nothing we can do to stop it. No spacecraft can outrun the stretching of space. No signal can cross that boundary. So as we scan the heavens and chart the stars, we are also racing against time. The sky above us is slowly closing, and we are among the last generations to see it wide open. Chapter 3. The cosmic event horizon, where light is left behind. Imagine standing at the edge of a great ocean. You watch a ship sail into the distance, smaller, quieter, until it slips beyond the curve of the earth. It still exists. It's still moving. But from where you stand, it's gone. It's the distance beyond which light, even traveling at the fastest speed possible, will never reach us. Not now. Not in 1 billion years. Not ever. That's exactly what's happening in the cosmos right now. The cosmic event horizon is not some science fiction wall or barrier in space. It's a natural consequence of how the universe works. Galaxies that are real, massive, filled with stars, planets, perhaps even life, are drifting into permanent invisibility. Not because they're disappearing, but because they're moving away faster than the universe lets their light travel. It's not because the light stops traveling. It's because the space between us and that light is stretching faster than the light can cross it. At a certain distance, estimated to be around 16 billion light-years, the rate of expansion exceeds the speed of light itself. That's the cosmic event horizon. Anything beyond that point has already crossed a line we can't follow. Let's break that down. But this isn't fantasy. It's a measured, calculated truth, a cosmic boundary etched into the fabric of space-time itself. Space isn't static. It expands. And the farther something is from us, the faster that expansion pushes it away. No matter how clever we become, no matter what future technologies we develop, the physics of our universe simply doesn't allow that information to reach us. Ever. Even galaxies we can see today, their light reaching us now may already be gone in another sense. Civilizations may rise and fall. Stars may be born and die. Black holes may collide. But none of it will ever touch us again, not even as a whisper of light. We're watching ghosts. We're seeing the last message they'll ever send us. We try to understand all while knowing that we are living in a shrinking window of visibility. Think about that. From our perspective, they're being swallowed by silence. Now here's where it gets eerie. That horizon isn't fixed. It moves. Every moment, more galaxies pass beyond it. And what lies beyond that horizon? We'll never know. Not through observation. Not through science. It's a hard limit on information, like a book with torn-out pages. In a way, the cosmic event horizon is like the edge of a dream, the place where reality fades into unknowing. And this leads to a strange and sobering realization. We are not just losing stars. We are losing entire timelines. Each galaxy beyond the horizon continues its story without us. So we watch, we record, we are the observers at the edge of a vast stage, watching the curtain slowly fall on the greatest show we will never fully see. But even as the universe pulls away from us, piece by piece, we still have questions. And one of the biggest is this. What lies beyond the horizon, not just physically, but fundamentally? Are we truly alone in our observable bubble, or is something else watching back? Chapter 4. What could exist beyond our reach? What if the real mystery isn't what we can see, but what we read not even allowed to imagine? Beyond the cosmic event horizon, Beyond the edge of our visible universe lies a realm we will never touch. No telescope can see it, no signal can reach it. It's not just far, it's forever out of range. And yet, physicists agree, it's there. In this view, our cosmos stretches endlessly in all directions. We're just one bubble in an infinite sea of matter and light, limited only by the speed at which information travels. But what is there? Some scientists believe the universe beyond our observable patch is simply more of the same, more stars, more galaxies, more of the familiar. But there's a deeper possibility, a stranger one. What if the regions beyond our cosmic horizon follow different rules entirely, different laws of physics, different dimensions, perhaps even different realities? Welcome to the world of cosmic inflation and the multiverse. According to inflation theory, the universe expanded unimaginably fast in its earliest moments, faster than the speed of light. In fact, but this inflation may not have happened everywhere at once. It might still be happening, spawning pocket universes with each burst of space-time. Some might look like ours. Others might be radically different, ruled by forces we can't even name. But here's the twist. Our observable universe is too small to rule any of this out. That's the irony. The very limit that keeps us grounded, the cosmic horizon, is the same limit that makes the truth unknowable. Somewhere out there, the constants of nature could be tuned so perfectly that life blooms in ways we can't even imagine. Quantum mechanics, string theory, and cosmic background radiation all leave breadcrumbs, subtle hints that our visible cosmos might be just one room in a much larger mansion. And if that's true, then beyond our cosmic event horizon may not just be more universe, it may be other universes. This isn't just fantasy. Mathematically, it fits. A mansion filled with locked doors. In one room, gravity might be stronger. In another, atoms might never form. And perhaps, somewhere a version of you is watching a different night sky, wondering the same thing. It's tempting to think this is all speculative, and it is to a degree. We might be surrounded by cosmic wonders beyond comprehension, and we will never know. Not because we're not smart enough, but because we are trapped inside a causally isolated bubble, floating in a sea of unreachable truths. So when we ask, what lies beyond the edge of everything we know, the honest answer is this: possibly everything, possibly nothing, and we may never find out which. But we can imagine, and maybe that's how we fight the silence. Chapter 5. When the universe goes quiet, will we be alone? One day, far into the future, the stars will stop whispering. Not because they've burned out, not because the galaxies have disappeared, but because their light will no longer reach us. That's the fate awaiting us in a universe ruled by acceleration. As dark energy continues to stretch the cosmos faster and faster, every galaxy not bound to us by gravity will vanish beyond the cosmic horizon. They'll look into the sky and see nothing, just darkness, an illusion of cosmic isolation. The night sky will grow dimmer, sparser, until only the local group remains. A few neighboring galaxies, Andromeda, Triangulum, and the Milky Way, all drawn into a final gravitational dance. Before the rest of the universe fades away, two of the civilizations that come after us, if any do, the universe will appear much smaller than it truly is. They won't know there were once trillions of galaxies when ancient photons still reach us, when the past still speaks. They won't know about the vast, vibrant web of stars that once stretched across space. To them, the universe will seem cold, static, and alone. A sliver of time when galaxies still call out to us, when their messages still cross the void, when the night sky still tells the truth. And the universe, now cold and dark, will settle into its final form, a silent expanse where nothing happens, because nothing can, but we know the truth. A cosmic graveyard, motionless, endless. We rehear in a fleeting window of clarity, the rare cosmic moment when the sky is still full. If the universe was once alive with light and sound and thought, we are the last generation to witness the full story of the universe. Let that settle in for a moment. You, sitting here listening to this, exist in a brief, golden era of light. Eventually, even the stars will die. First the bright massive ones, then the smaller ones. Even the long-lived red dwarfs will cool. Planets will freeze. Black holes will evaporate. This is what some call the heat death of the universe, a time when entropy reaches its maximum, and all usable energy is spent. If you've stayed with me this far, into the quiet edges of space, there are more stories waiting just beyond the edge of light. Leave a comment, a thought, or even just a name, so we know someone's still out there, wondering, and in that silence, the question lingers: will anything remember us? Will some distant observer trapped in another pocket of space ever wonder if there were others? Or will we become a forgotten dream, flickering out before anyone could notice. No one knows. But maybe, just maybe in sharing this story, in wondering aloud together, we resist that fading just a little longer. Maybe every thought, every question, every human glance toward the sky keeps the universe listening, even if it never answers back. The universe keeps expanding, and so does our curiosity, bit by bit, moment by moment, toward the unknown. Don't forget to like, subscribe, and ring the bell.